Was Neil Diamond, and that was something about blue jeans? Forever in blue jeans. I can never remember the first part. Forever. Infinity in blue jeans. Infinity in blue jeans. Forever. So we're getting some papers around, and just these are homework papers, so as they come back, take a look at it. We have a quiz that we're about ready to do, so the question is, what kinds of questions do you still have about 14 through 18? That's what we need to do. 18, well, that's a good age, but do you have a question on that one? Or?
How do you get a...
Okay, we have some questions. Which one is it?
5D.
5D, which was 2/3%, right?
Yep.
And we want that as a what? Common fraction. So we want 2/3% as a common fraction. So we'll go to the board, Ernie, for that. 2/3%. Now I'm writing it this way. I just want you to realize that oftentimes it'll be done this way to keep everything in one line. So the question, what does a percent mean? And I think that's the nice way. 1 over 100, correct? So if you think of these just sort of being multiplied by each other, that might be a nice way of thinking. You don't want to reduce at this point, although you could. You could just say 2 over 300, and that would be something I'd like you to realize. But what this does allow you to do, and then you get 1 over 150. Now, another way of thinking of it, we talked about the complex fraction. And when I did this originally, I did not write it this way, Adrian. I went ahead and said it was 2/3 over. Otherwise, that says as a, I didn't say that right. What am I doing there? That's over 100. I started to invert there, and I don't want to. That is over 100, because percent means over 100. Now, at that point, that means 2/3 divided by 100. And you'll note the next step would be exactly what I have here. 2/3 times 1 over 100, because this is understood to be 100 over 1. So you have a choice. I presented it this way the first time. And I sort of like this also, because it's a little more efficient. Question? Teresa. Okay, well, just a minute. Are there any more questions on D before we leave this? This is 5D, I believe.
Yes.
Number 5D, and this was to go from 2/3%. While I'm here, I don't want to let this one go yet. What happens if I want it as a decimal? Again? Okay, I could divide 3 into 2, and what would I get?
1.33333.
No.
3215.
No. 2/3. I want it as a decimal. Anybody? 2/3. Yeah, it's a sick problem. 0.666 forever, or you could say what? A line over it, or you could dots with the percent. Probably be a little bit awkward. I like this one. But you have to be careful, because I still have what? Still have a decimal. Remember, 1/3 is 0.3333, so 2/3 is twice that for your 6's. Now this means, now be careful. Well, that's still, I'm not done yet, because I want it as a decimal, and so far all I've managed to do is get it from a percent to something over 100, but I can rewrite this as what? Power of 10. Yes, and then move the decimal point 2 places to the left. So finally, what do I get? Be careful, be careful. I haven't heard a decimal point yet. That's what's bothering me. Would you like to give me a decimal point, Adrian? No. It's point. What? Then I'll take what Adrian said. 0, 0, 6, 6, and 2/3. Okay, we got it? I just couldn't pass that one up. I know that wasn't part of your question, but I returned a gift. Okay, there was a, what one was it, Teresa? 5e? So 5e, well, it's 7.5 what? Number 5e. Okay, so 7.5%, and I want it as a what? Common fraction? Okay, we'll do it two ways. Both as a common fraction and as a decimal. Your request and then my request. Okay, what does it mean to be as a percent again? It means over 100, right? So I can go ahead and say 7.5 over 100. Now if I use this little shortcut that I started with where I treat percent as 1 over 100, I could have said that's 15 over 2%, correct? Yeah. That would give me 15 over 2 times 1 over 100. And I could immediately start doing what? Reducing. But note, this will equal this. Because this is 15 over 2 over 100 over 1, which means 15 over 2 divided by 100 over 1, which will bring you right back up here. Because this divide by, that didn't on the screen look very good, that's better, becomes this. Now what am I going to do? Cancel, can I not? Mm-hmm. This ends in a 5, this ends in a 0. Both can be divided by? By 5. Can't do a 3 into here, but I can do a 5 here. So that'll give me a 3. This will give me a 20, and it looks like I have 3 over 40.
Okay, that makes sense.
Okay.
Now, I've been given the blessing. Okay, now, if I want this to a decimal, I can change the 7.5 right here to a 7.5, but note it's still what? A percent. So this means 7.5 over 10 to the second, which means 2 places to the left, 0.75. When we divide by a power of 10, we go to the left. When we multiply by a power of 10, we go to the right. Does that answer that particular one? That was 5e. Anybody else in 5e?
Nobody got
One more. Okay. Which one?
3D.
3D?
Yeah, 3D.
Like two-dimensional, three-dimensional? Okay, so 3D problems. And this one is 1.25.
We just want to know I was
1.25 is a what? What am I supposed to do with it? As a percent? As percent, which means I want it over what? 100. Now, as it stands, I could just do this. It's over 1. How can I get anything over 100? Multiply the denominator by 100. Basic principle of fractions, what I do here, I must do to the top. What does that do to the decimal in the top? Yeah, it does, because it moves to the right. This is, maybe it would help if I did this as an intermediate step. Remember, I want it over a percent, so I don't want to do anything to this. Now, that moves the decimal 2 places to the right, which technically is there. But if you have it at the end, what are you allowed to do? Just throw it off, throw it out, and it is simply 125%. Now, one of the awkward things is with percents, we oftentimes have in mind that 100 or less. But there are times that percents go more than 100. So for example, if I went ahead and I bought something for a business and I paid $50 for it and I sold it for $100, okay, my retail price at 100 is twice the cost of $50. So if I look at the retail price as a percent of the cost, it's 200%. If I look at the markup, which is $50, cost $50, that's 100%. And we have certain businesses where the markup may even be more than 100%. So if I have something that's really in high demand, so I go out and buy a piece of antique furniture from somebody who doesn't know its value, and I don't tell them. Question of ethics there. But I go to a garage sale and I see something that I know I can sell for $1,000. And the person's asking $100 for it.
Not 10 times.
I will go ahead and pay them the 100, and I'm going to get 1,000 out of it. So that's 10 times, that is 1,000% markup. Or not markup, but retail over cost. So yes, those things happen. Other areas, oftentimes, what we consider, I'm trying to think of the word, accessories is coming to mind, but you buy a camera, and then you want a camera case for it, and then you want a flash attachment, maybe supplementary, and things like that. The camera may be nearly at cost, but if you want to have something to have with the camera, I'll charge you markup maybe of 200 or 300% to make up for what I lost. Okay, that's the idea. Other questions on these problems? Okay, let's do a little bit of a review. These are things in 14 through 18 that we've been talking about. So let me just ask you to do some of these. You'll need some paper out. We're just going to spend some time this morning having you try some problems, and let's see if things are going okay. So I'm going to start with a problem which has a trap associated with it, so be careful. Okay, this has a potential trap. So I'm going to take 20 minus 370, well, let's take 325. I'll do this. 20 minus 3.25. I wrote it in a pre-algebra format. I'd like you to give me the problem now. Just write the solution out. The one in the far upright corner of the board. It's on the screen as the far upright corner of that. And while you're doing that one, let me just do another one below it that I'll write down. With the directions round off as needed. So that's 3.6, 2.756, and 11.35. So these are two problems I'm just asking you to do. A little bit of review. The first one I hope you've had a chance to write and do. But I'll give you just a little more on that. Now this one has a potential trap in it, so be cautious. Okay, that first solution. This would have been the safest way to do it. No, this is just subtracting, and so I put the decimal point and some zeros here. Now, whether or not you want to do the borrowing or you want to do the Austrian method, I'm going to do it for once as a borrowing problem, just to remind you how messy that can get. Looks rather messy. Remember the decimal at the answer point. So that's a 5, a 7, a 6, and a 1. 16.75. Now the error, if you got trapped, was 17.25. Okay, so this is the correct answer here. Now the next one, I'm going to just rotate a little bit and write the numbers over here. So 3.6, 2.756, and an 11.35. And of course the key, I want to do what? Line up the decimal point. Now what's your next thing that you try to do? Go ahead and fill in some zeros to make it easier to add your columns. Okay, so that's going to be a 6. Then you had the 10. Then what? 17. Remember the decimal point. Carry the 1.
7.
So a 7, no carry, and a 1. Now how do I round off? What should be my answer?
17.71.
Now I've heard of 1771. That would be good to the nearest hundredth if I ask you to the nearest hundredth, but I ask you as needed. How does that change the game?
20.00.
What was the least precision I had in my numbers? Here I had it to what? The 10th, here to the 1000th, and here to the 100th. So the least precise was the 10th. So this should be written as 17.7. Now, if I'd ask you to go to the 100th, that would have been a different story. Okay? Any questions on that before we leave this part of the board?
I take it that's on the test.
That could be on the test, on the quiz. Okay? Any questions there? Adrian?
I just want to say, like, I was always used to putting the biggest number on top.
Oh, you can put the 11.35 on top, yes. Because in addition, you can do what? Rearrange them any way you want. Okay? So, coming back over to here for a moment. And Ernie, that frees up camera 2 over to the side, please. Now, most of you wanted to go to the 100th because a lot of the division problems I've given you have had what direction?
100.
Write out the answer to the 100th. So that was the kind of thing we did in lesson 17. So let's just look at a typical problem there. And remember, this was the direction we had in this kind of problem. It stopped. Okay, Ernie, let's go to that. This was your direction here, right? Now, just a reminder that one of the problems we had, I asked you, I believe, to do something where you had 1, 2, 3, 4 into 4, 3, 2, 1. Let's try a variation on that. 1, 2, 3 into 3, 2, 1 point, and I'm going to ask you to go to the nearest hundredth in your answer. So if I'm asking you for hundredths, rounding off. So the argument here, round off to the nearest hundredth. That would be my direction. Then I only need 3 digits after the decimal, because once I get to the thousandths, I ask if it's 5 or more, and then I round off to the nearest hundredth. Go for it. Let's see what you get. Okay, just see what happens here. We'll just leave that up on the board for a moment. You need to write down the problem, carry it out. Your first digit comes pretty easily. Let's see what you get here as you do the division. Just waiting for people to do some work here. The division itself is made more complicated in a sense, I think, by asking you to round off your answer to a certain spot. Okay, now I think most of you have probably taken your first step here at 246. And then, depending on how you think of this, I hope you have managed to get a 7.5. And then you had to do what? Bring the 0 down. Now, is it 5 or 6 that's going to work here? 6. Okay, I hear a 6 profoundly stated. So you had a 6. And what did you get with the 6? 7 what? 738. Do we agree with that? If so, that gives us a 12 here, which is rather interesting. Because what happens when I bring down this next 0? It won't work, so I have to throw another 0 in up here. And then remember at that point to bring down yet another 0. Okay, now whether it's 8 or 9, it's going to be one or the other. I don't really worry. I don't have to do that. Because what was I going to do? Round us to the nearest hundredth, which means this is the digit I'm worried about. And as long as this digit is what? 5 or more, that's going to raise this 0 to a 1. So your answer is a 261. So you save yourself some headaches in the process. That makes it rather nice. Okay, let's do another one. This is one that I think I'll just write out this way. I'd like you to write it in expanded notation for me, please. Expanded notation for me. So I have a 37.0256, and I want it in expanded notation. So a 37.0256 in expanded notation. And by the way, you have a choice here. If you want, you can go ahead and use negative exponents. So your choice. Negative exponents are okay. So expanded notation. Negative exponents are permissible. So we have a 37.0256. Expanded notation. And if you've got that done, and in verbal notation. Verbal and expanded both. So let's see what we can come up with in this. Verbal and expanded. Okay. Giving you some time to write out your solution. Okay, I want it in expanded. So for expanded, I need to know what? The powers, the place value, agreed? So we have 3 tens, because this is ones and then tens. So I would go 10 to the first plus 7 times 10 to the 0 plus, be careful here, 0 times negative 1, which is the same as 1/10, right? Then plus 2 times 10 to the negative 2, which is 1 over 100. You could have done that instead. Plus 5 times 10 to the minus 3, which is the same as 1 over 1,000. Plus 6 times 10 to the minus 4, which is 1 over 10,000. That would be your expanded notation. Who wants to give a shot at, okay, Teresa, go for it.
37 and 256, 10,000.
Very nicely done. 37, so let me write what was just said. 37. Now I like to use and for the decimal point. Now you know you have 256 or something. 256. I should not have said and. But what is it? Tenths, hundredths, thousand, 10,000ths. So I have 256 and then what? 10. And I like to, at this point, put a hyphen. Thousandths. You have to have the THS, and that would be verbal notation. Okay. Now, let me change the problem slightly. If I had just done this, just a reminder, instead of saying 256, you could have just said 25 thousandths. But notice what happens the minute I make that a comma. And you have to be a little careful because there are places in the world where that means a decimal. But this would be 37,025. And in expanded notation would be, okay, this is ones, tens, hundreds, thousands, 10,000 plus 7 times 1,000 plus 0 times 100 plus 2 times 10 plus 5 times 1. Notice the difference between this and this. Well, I could have written this in powers of 10. 3 times 10 to the 4th, 7 times 10 to the 3rd, plus 0 times 10 to the 2nd, plus 2 times 10 to the 1st, plus 5 times 10 to the 0. But I'm still wanting you to compare what? This to here, where in this I have negative exponents. I don't have them here. A very big difference between the decimal point and the comma. Are we okay there? Lovely? Uh-huh. Yeah. No sincerity there, I can tell. Okay, let's slide over now, if you would please, Ernie. Slide over with me. Thank you. Now, in this problem, let's try another one, the kinds of things you've been doing. I'm going to use a shortcut. So can we come in a little bit tighter for the top part so people can see that a little bit better? Thank you. 1,000 times a 5.2376. Contrast that to this problem. I want you to rewrite both of them. I'll change the problem slightly, but rewrite them with powers of 10 and use the shortcut. Doesn't take very long if you know what I'm asking now. So use shortcut. That would be my directions here. So use shortcut, and I'm going to ask you to write with powers of 10. So with powers of 10. We'll see what you can do. One step and then the answer. So you'd write down the problem, show one intermediate step, and go with your answer. So I'm taking this 1,000 times 5.2376 with the shortcut. That's what I want. Again, giving you time. Okay, now the first one, what I wanted done in that was to rewrite the 1,000 as 10 to the 3rd times the 5.2376. And by the way, just note, that is the same as this statement. So you can see it either way. But what am I supposed to do with the decimal when I multiply by a power of 10? 3 places to the right, because the exponent's 3. So that means it's going to go between the 7 and the 6. So 5, 2, 3, 7.6. By the way, what is this form called that I have the double check on? Very good. Scientific notation. Because it's 5 point something times a power of 10. Okay, what about this one? You have 5.376 over 100, but that can be written as what? Very good, as 10 to the 2nd. Okay, now, I'll get to there in just a second. So I have this. So my shortcut at this point, dividing by a power of 10, is indeed 0.05376, as one of you said. However, coming back to Travis's comment, this is going to be the same as, that's looking at this and rewriting it. How can I handle this problem? What is this the same as? Well, that's the same as 100, but very good. 5.376 times 10 to the negative 2. That's looking a little bit too close for comfort there. Let me try making this negative 2 there, and I'll put this 1 over 10 to the second. Okay, and my point is, this again is in what form, Travis? Scientific notation. That is still a number with the decimal after the first digit times 10 to some power. We got it?
Yep.
I hope. Okay, another problem. We've done division. We have done converting things from one form to another, expanded notation. What if I just gave you this problem? Let's see what I want here. Okay, 1.44 times 1.2. We've used this one as an illustration a couple times. Let's pull that in a little bit tighter so people can see the problem. Now, carry it out. It shouldn't take you more than just a moment or two to do that multiplication. Now, you may already know that one in your head because that's 12 to the third power that I've got involved. But let's see what you get. Just to remember where you place the decimal point. That's my concern. Okay, we have a 1728. I'll agree with that. Here's what you should have written as your solution. The 288, then the 144 is in this form. You don't worry about a decimal point up to here. You write down your 1728. Now, where do I locate the decimal point? Okay, I have 2 digits here after, 1 here. That's a total of 3. I want 3 there. So you can just locate it so you have the decimal point there, or you could have said it is at the end. If you don't see it, move 3 to the left, and you've got it. Any questions there? So we've added, we've subtracted, we've multiplied, we've divided. We've gone from percents to decimals, fractions to decimals. Let me just do this one. What is this as a common fraction? As a common fraction, 0.125. How do you approach it? You can make a fraction out of it by saying it's over 1. What's bad about it? There's a decimal in the numerator, correct? I can get rid of that decimal by multiplying by 1,000 there and 1,000 here. So it's really 125 over 1,000. Okay. I had a different problem there. That was 1.25%. That's a very different problem. This is just 0.125 over 1. This is 125 over 1,000, and you reduce that. How many quarters in $1.25? 5. How many quarters in this? Okay. 40, right? And what does that reduce to?
1/8.
That's one way of doing it. Or, remember my little list? You don't like this list. I thought this list was good. 0.500 is 1/2. 1/2 of that is 1/4 for your 0.250. Then take half of that, which is 0.125, which makes 1/8. So you can go that route. Okay, Ernie, this has been a short presentation because we're going to have a quiz in here.